Okay, so I'm gonna have to adjust the volume. Today, along with several weeks, we're gonna be talking about this topic of biodiversity. Okay, so how would you guys describe biodiversity if you actually broke down? How would you describe biodiversity if you actually broke down the word? What does bio mean? Living. Diversity means different or variety. So that's what we're talking about. We're talking about a variety of different living things. Okay. So we're going to talk about not only biodiversity, but we're also going to talk about this topic of evolution. So when we talk about biodiversity, for the most part, if you were to look it up online, most other websites and whatnot, sources would list these three: genetic biodiversity, species biodiversity, and then ecological biodiversity. The book kind of creates another one, which is totally fine, and we'll get into what that means. But for basically what we're dealing with is these different natural processes, these cycles. That's where the functional comes into play, okay? So what we're going to talk about literally for a couple of weeks is what's so important about biodiversity, especially how does it help support, keep us alive, and then as far as the economy is concerned with biodiversity, okay? So these are those different types of biodiversity. First is the genetic diversity. That is how genetically diverse either a species or a population is. Because we've talked about this in other classes of mine. Why is diversity so important? Why is genetic diversity so important? Because the less diversity you have, the more go wrong and the faster it can go wrong. Okay, if I have 100 individuals in this ecosystem versus maybe only 10, well, I can take out a few individuals and yeah, there's going to be an effect, but maybe not as major. Versus if I only have 10, there isn't much room to play around with, okay? So the genetic diversity. And we have species diversity. How many of that species are there? And not just how many of that particular species, but how many species are there? Okay, so it's kind of twofold there. So how many numbers, how many do we have of that particular species? Then how many species overall do we have? The third common diversity is ecological. And when we talk about the ecosystems, we're not only talking about the terrestrial, but we're also taking into consideration the aquatic ecosystems. And then the fourth one that your book has is, again, the functional diversity. So that is any biological or chemical cycle that we naturally have. And we're going to be going through this throughout the semester, whether it's the carbon cycle, you have the nitrogen cycle, you have the water cycle, all these different cycles that Mother Nature naturally provides. Okay, how well are those actually functioning? So there is an individual, his name is Edward Wilson, and he's kind of known as like the father of biodiversity. He's the one that made everyone aware just how important this word is, topic. Okay, when a lot of us have grown up, but when we're growing up, especially boys, we're always interested in bugs. Well, as he said, he never outgrew his bug period, and the bug he really became interested in were ants. He started realizing, this tiny little creature, just how strong they are, how they're able to communicate. Okay, he was really fascinated with that. So, if you really want to understand and study an organism, the real way to understand the organism, you have to look at the environment it lives in. Otherwise, you're really not going to understand everything about it. Okay, and that's what he started realizing. If I really want to understand about this particular ant, I don't look at just the ant or how they interact with one another, but how it actually interacts with the environment. So that's what he did. So he's written many, many books. The big one that he's actually known for is The Diversity of Life. Okay, and basically, he said if we don't have this diversity, basically things are going to start going extinct, and that has already happened. within our lifetime, there has been certain species that has gone extinct. So that brings us to where and how did species come about, okay? There's certain things, certain topics in this class that we might talk about, or any class for that matter, and doesn't necessarily mean we believe. When I say we, as in Neville and I, doesn't necessarily mean we actually agree with that concept or that topic, just like what he pointed out earlier. You might not really think sustainability is all that important. You might not agree with it, okay? It's a concept that you have to learn within this class, and so that goes with evolution. It doesn't necessarily mean that we agree with this process or this way of thinking, okay? So you can have like the science way of evolution, how species came about, or you might believe, within God's creation. But we're going to put it out there, and it's up to you to decide whether you believe this way or not. So with evolution, we have what's called natural selection, okay? And this is implying how life changes over time. It just doesn't happen instantly, okay? It's a gradual process. And again, if we're talking about geological processes, even hundreds or thousands of years geologically, that's really not that long of a period of time, okay? Because when we talk about geology, we're talking about millions, even billions of years, okay? So with evolution, you have these traits, and typically the traits that helps a species survive becomes more evident, okay? And what happens is, what we rely so heavily on for this evolution, okay, is fossils. That gives us physical evidence that this species actually did exist, thousands of years ago. And we have a lot of unanswered questions in evolution because of this fossil record. What happens to fossils? Everybody wants. They get mineralized, okay, but they also get destroyed through different, natural processes. So there's always going to be these holes and these gaps through this evolution process that we're never really going to know, which I find that's what's so cool about science. Right when you know one little thing, that just opened a whole nother can of worms. You're like, man, right when I thought I was understanding things, then you realize just how much more you don't know, okay? So with evolution, okay, what happens is we can have these mutations, and these mutations, there becomes adaptations. A lot of times people think of mutations as a negative thing, a bad thing. Like, a mutant means you have 3 eyes and 5 arms, that sort of thing, which is not true. A lot of times these mutations, especially when you talk about plants, it ends up being a beneficial factor in order for it to survive, okay? So the way these populations keep going through time is basically that they're genetically different. Again, that whole biodiversity. And so within the steps of evolution, what you have is these genes mutate, and the way they can mutate is just through environmental factors. Maybe there was an oops moment when we had the chromosomes crossing over and everything, so there can be different reasons for these mutations. So you get these mutations, and assuming that it's a positive mutation, beneficial, then those are what's going to allow that species to keep going forward, and these populations are going to evolve. And typically what happens is, if that species is better adapted, then they're going to keep continuing. If they're not adapted, they're not able to reproduce, okay, well, there could be environmental conditions that could prohibit that as well. But if you don't have these adaptations and survival methods, then that species is eventually going to become extinct. So this diagram here is taken out of your book, figure 3.2. What this is showing you is this natural selection process. So the blue ones are your normal bacteria, and then the red ones are the resistant. So when you go to give medicine, that's not the word I wanted. What I want, no. Sorry, I put them on the spot there. Antibiotics. Okay, the problem that we have nowadays is that our bodies are becoming resistant to these antibiotics. Okay, and so what happens is you have your normal bacterium that would normally get wiped out with the virus. But then you have these other ones, these red ones that are naturally resistant. They have the genetic material that allows them to be naturally resistant. So when you take these antibiotics, it's going to wipe out the normal ones, and then which ones are left behind to naturally reproduce? Those resistant ones. Okay? And what's happening with our bodies is we have what's called the, like the superbug that can be used in different ways. But the superbug, basically our body take these antibiotics, and we're finding out sometimes it doesn't knock out whatever that bacteria. And because these bacteria are becoming resistant to the antibiotics. So one of two things has to happen. Either you have to come up with a stronger dosage, and then eventually what will happen with the bacterium, they'll get resistant to it, or you come up with a totally different type of antibiotic as a result. Okay, so this is what we're up against. People that get infections very easily, they're having to get higher and higher dosages to try to not necessarily even knock it out, but just maintain. So adaptation, okay, you have these traits, and these traits theoretically are supposed to allow you to continue in these different environmental conditions. Okay, and we'll get into more an example of that. So there's what's called reproductive capacity. It's how a species can reproduce, how fast it can reproduce, basically. Not only can it reproduce, but how quickly it can reproduce. So think of an elephant, okay, versus a bacterium. How fast do bacterium reproduce? Well, basically you blink and now you have like 100 instantly. Unlike an elephant, how long does it take for it to have any offspring? It carries the baby for like 2 years. So the bigger the organism, the longer it takes to reproduce. And there's a big disadvantage to that. If it's going to take 2 years before that baby's even ready, you're obviously not able to repopulate that species very quickly. And it's easy to wipe them out faster. Unlike bacterium, it's very difficult because of how fast they reproduce. Okay, so for these organisms that are able to reproduce very quickly, okay, that's totally in their advantage because that allows them to keep their species, their population going. There's myths with the natural selection. First one is called survival of the fittest. People kind of use that interchangeably with survival of the strongest. Oh yay, we get a clock, Neville. Quarter. It's a little things in life, sorry. How you doing? Come on in. Please do. Yeah, either the back wall or over there is fine, either way. So survival of the fittest is not necessarily survival of the strongest, because when we think strongest, we literally think, how physically strong. But I could be physically strong, and that doesn't mean that I'm genetically fit. Okay? Organisms do not develop traits out of need or want. So right here, these giraffes, if I want to get to this taller foliage, the taller leaves, the leaves that are up higher, I'm going to grow a longer neck. They don't have control of how long their neck's going to be. That's their genetic. Okay? But it makes sense that some giraffes have thank you, that was very quick. It makes sense that some giraffes have longer necks and some have shorter necks, because that way they're not competing for the same level of leaves, same food source. Okay? And no matter what plan we have, there's no plan that is perfect. Okay, Mother Nature always, I always say she has the last laugh, and we never know what's going to be in store. So there's nothing that's ever perfect. Everything gets better through time, but it's still never perfect. So as far as the natural selection, what can change it, a lot has to do with plate tectonics. Okay, think about back in the day, we had what was called Pangea, right? That's when all the land masses were together, because people were like, well, how was the woolly mammoth that was down in I don't know, South Africa here in Montana. Well, how did they do that? Well, we had this one continuous landmass and it allowed for the migration of those animals, okay? But with that, we also have these plate tectonics. They shift, and that shifting is earthquakes. The shifting causes mountain ranges, and that can isolate a species off, okay? And then we have volcanic eruptions. That destroys things as well. And then with these climate changes, I know there's a lot of controversy with climate change, and the way I like looking at it is I don't think there shouldn't be really any controversy if there's climate change, because the earth naturally heats up and it naturally cools down. It's a cyclic pattern, okay? Where the controversy comes into play is based off of our human practices. Are we speeding up that process? And right now we're in this heating up process. So because of whatever practices that we do, driving our cars maybe more than we should, that sort of thing, are we speeding up that heating process? Okay. So we did have that cooling down stage, the ice age, and then it went this warming trend. And then, you know, there's other theories out there too. Well, then there was collisions, the asteroids, meteorites, and with that, what can happen is you can have automatic mass extinction right then and there, because you could have that species that lived in a very small region, and it happened to be that meteorite hit that particular spot, okay? But what can happen as well is new species can come out of it, again, if you believe in this evolution. Otherwise, the God way, the species are already there. So with your temperatures, if you think about it, it's pretty amazing where the Earth is located in relationship to the sun, okay? Because if it didn't rotate as fast as it did, that would mean that one section would heat up too fast and the other side would stay cold too long. Same thing if we were too close, and we would really be too hot. So it's really amazing the proximity that the Earth is to the sun as far as our temperature, okay? And then we have the oxygen content. Despite what most people think, the atmospheric air that we breathe isn't mainly oxygen. Do you guys know what component it is, what element? It's actually nitrogen. And it's like, well, why would it be nitrogen and not oxygen? I mean, we think oxygen because that's what we need. But where are we actually getting the oxygen from? Plants. And the plants need the nitrogen. Okay, so that's why we have mainly nitrogen within that. But we have this carbon cycle, and again, that one type of biodiversity with the function part of it, this whole carbon cycle goes into play. So how do we get the species to evolve? There's this term speciation. That's when you can literally have one species and it splits into two. And it doesn't mean like I'm an amoeba and I'm able to split myself into two like that. We'll get into how that happens. But it can become geographic reasons. So what can happen is you have this isolation due to geographic reasons, such as a glacier or a mountain, something really major like that. And basically it gets isolated, and then what will happen through time, and again, not just tens or even hundreds, but thousands of years, then you're going to have a whole nother species evolve from it. Then we have what's called genetic engineering. That is what I want. Yeah, genetic engineering. And you guys might have heard of this in the past. It's called GMOs. You guys have heard of that? Genetically modified organism. And I say organism because that could mean any living organism. Typically, we think of it along with plants, but it can be animal related too. And so when we genetically engineer these organisms in the lab for whatever reason, now the reasoning for it was actually a good thing. We don't look at it as much of a good thing anymore. And part of the reason is because we don't know what the outcome is taking in these genetically modified organisms, what it can do or is doing to our body. But the whole reason why they came up with it initially was to make plants basically drought tolerant to these countries such as Africa That way they're not so dependent on other countries for their food source. They have very limited water. What water they do have usually isn't good water quality. And so they started engineering these plants to where they could grow their own food. But again, as we started seeing, well, we can modify these plants to basically so it lasts longer, okay? So instead of maybe producing 5 or 7 ears of corn on a plant, maybe it can, even if it increases just 1 ear of corn, instead of 5 to 6. But if you increase each plant by 1 to produce by 1, that starts adding up, okay? So as far as speciation with the geographical isolation, so we had this population of fox, okay? And then they came to a point where they decided, well, this group wanted to head north, so it did so, and this other group went south. Okay, so they're in very different geological or geographic areas. So that northern population, what they say happened is the color of the fur was completely different. Okay, that way they're camouflaged with the background, right? Versus the gray fox, now they're camouflaged with their background. But they have a heavier coat because they're in a colder climate. And as far as their ears and their snout, they're much shorter. Think about like all our animals, whether it's the fox, whether it's, like the jackrabbit. Our animals here in the desert, they have long snouts, they have very long ears, and that's so they can get rid of the heat. Here, do we want to get rid of heat? No, we want to keep it, okay? So that's how, due to geographical differences, how through time we can actually, there would be different species that come out of that. So as we were saying with the GMOs, okay, one of my classes I have them do what are called current events. It's for environmental horticulture. And what one student did their current event on was GMOs. I'm like, okay, well, let's see where this is going. But I thought it was pretty interesting is they're trying to genetically modify plants so they can photosynthesize better. I'm like, well, that one sounds good, okay? But again, we don't know what repercussions that food will end up having on our bodies. Yes, ma'am?
There's actually a documentary that explains all the effects of what GMOs do to our bodies.
It's to where they have documentation what's actually happening now. What is it called?
Seeds of Death.
Oh, Seeds of Death.
Yeah.
Oh.
On YouTube.
I'll have to, check that one out. Have to look into that, Seeds of Death. So here we have genetically modified salmon versus your farm salmon. Well, why would we want to do that? We have a fish hatchery, okay? They don't genetically modify them. They do something differently to get the animals grow faster. But that's basically why they're genetically modifying any plant, any animal, a lot of times is to grow faster, grow bigger, okay? So with this genetically modified salmon, it grows 24 inches and about 6.5 pounds versus a farm salmon is only 13. It's half the length. And look at the weight, not even 3 pounds. So you're getting a heck of a lot more bang for your buck out of the genetically modified. It's going to be bigger, okay? Therefore, I can get more for my money. And this is over the same time period too, over 18 months. So we're getting more animal within the same amount of time. So, there's a lot of ethical debate. Every year there's these marches, even here in the high desert, it usually starts around the mall, and it's the march against what's called Monsanto. There's certain companies that I
know Monsanto.
Yeah, so there's certain companies that are known for this genetically engineering of the plants, and this stuff is really crazy stuff, okay? Farmers that plant these crops, if that seed they can't reuse the seed. I mean, it'd be really smart if you guys have your own gardens to save the seed instead of having to go out and buy new seed. Save the seed from the plant this year, and then that way you can replant next year. Okay, hold on one second. Now I lost my train of thought. Hold on. And with the farmers, they can't reuse the seed because there's a patent on that seed. So if they want to reuse the seed, they have to rebuy it. They have to buy it back from the company, even though they have the supply on hand. Or let's say there's pollination that occurs and it drifts over to the, Joe's farm, they can get sued as a result, even though they had no control of that seed blowing over and starting to grow. That's how crazy it is. Yes?
Are you talking about Monsanto?
Monsanto is one, but there are others as well. Yeah, that's kind of like the big one. Yeah. And it becomes very political too, which I won't get into. That's like a whole topic in itself. So extinction is forever. There's this term called endemic species. That species, it only lives in a very particular part of the world. A lot of times it's a very small region. Okay, and because of that, because it only grows in one small area of the world, it's very vulnerable of going extinct. We have an endemic species here in the high desert. You guys know what it is? Kangaroo rat? The tortoise, the desert tortoise. Yeah. Joshua trees. So notice what you guys have been naming off. Those are all endangered species, except for the Joshua tree that I did name off. That is not endangered yet. Okay, a lot of people think it is. It is protected by the county, but it is not an endangered species. And I say yet because they've been doing, research with that due to the climate change, warmer weather. The Joshua tree actually needs some of that cold weather that we get in the wintertime, and it's getting less of that. So its range is becoming more narrow, and it's just not as healthy as it used to be. So endemic species is only found in a particular area of the world. So you're not going to find the desert tortoise down in San Diego. You're not going to find it in Chile. You're not going to find it in Norway. It's only here in the Mojave. Okay, so that's what endemic species. Again, the disadvantage of that is because it's usually such a small area, it can be very easy for it to become endangered and eventually extinct. So a lot of our biodiversity loss is due to human activities. Not all of it, but usually when in doubt, you can say like habitat destruction, and that's because of human activities. Okay? So what's next are these biomes. And basically the biomes are characterized by two different things. The climate, and that overall dictates what type of vegetation is going to be able to grow. Okay, if it's too hot, this plant isn't going to grow. If it's too cold, well, now this plant isn't going to grow. So the climate differences, there is a difference between what is called climate and with the weather. Weather is what's happening right here and now. The weather right now I can do it because we have a clock now, at 9:40, it might be very different than what it'll be at 3 o'clock this afternoon. Some days will start off really nice, and by the afternoon it's really windy and it'll get cold. Okay, so that's what the weather is. Climate is just an average of these weather patterns over a period of time. Typically, what can we expect the climate to be this time of year? Okay, so it's an average of not only precipitation, but also temperature. So climate is an average and it's long term. And it's considering what the weather happened year after year at this time of year. So let's see here. With your biomes, all these different factors influence what is going to be able to survive there. Okay, latitude, precipitation, temperature. But a really big one that we don't probably take in consideration a lot of times is these large bodies of water. Whether you're talking about a really large lake, okay, or you're talking about the ocean. You guys go to San Diego, you go to Long Beach, wherever you go to the beach, okay, there isn't much variation between the summer temperatures and the winter. 85 to 55. That isn't much of a range. Okay, that's for the whole year. Our range, that's it during the day. Okay, our high today, 85 versus low being 55 just in one single day. So we go through these very extreme ranges. So the major types of biomes, as far as terrestrial are concerned, are these four right here. This is showing you here basically you have the latitude, and the closer you get to the equator, it's going to be wetter and hotter, and the farther north or south that you go from the equator, it becomes colder and drier. Okay? And when it becomes colder and drier, what's happening with our vegetation there? It's not as abundant, okay? And there's not as much diversity to it as well. It becomes more limiting. And the reason is because of that cold weather and because of the lack of rainfall. So this is showing you here just on a global basis. When you talk about forest, if we go back, okay, it says forest, but there's a lot of different types of forest. And that's what this is showing you here. You can have a temperate deciduous forest, you can have temperate rainforest, you can have a tropical rainforest, you can have a tropical dry forest. So a forest that's very vague, okay? So you can break it down even further. So you can see which of these biomes are bigger in number, okay? You have the coniferous forest, which there's a heck of a lot of. So again, when we talk about this destruction of biodiversity, unfortunately, more often not always, okay, but more often than not, it is human influenced. And so again, throughout this whole semester, we're going to keep coming back to this topic of natural capital, okay? What does Mother Nature naturally provide from us that we need, such as water, okay? We need that, and that's what she provides for us. So with that, yeah, we need the water. No two ways about it. But what we need to do is one of two things. Protect these wild areas from being developed. And if these areas have been developed, then what we need to try to do is restore them. Make them a better quality. So what sort of destruction have we done to the natural capital? When I first started learning this material, and you learn about all these different types of pollution, and the two types of pollution you typically think of is air and water. But then they introduced this third type of pollution. I'm like, what? What's that all about? Okay, light pollution. And it's a big thing. I mean, think about when you go to Las Vegas. Hello, I mean, you can see it from outer space. Any large city, you can see that. And they started doing studies. They're like, it has to have effect on things. Okay, being bright like that is, disrupting sleep cycles. It could maybe disrupting migration patterns.
Scaring me half to death.
Scaring you.
Terrifying.
So, when you have these large cities, there's a lot that happens. Okay, all these you probably knew about. But again, like I said, you guys probably, I didn't even know there was this thing called light pollution. As far as grasslands are actually highly productive, okay? The grass is really good for holding the topsoil. That's assuming that you don't overtill your soil like they did back in the 30s, and we had the Dust Bowl happen as a result. So what we've done with these grasslands, we took these grasslands and we converted it into agriculture, okay? And there's a lot of overgrazing that happens with the livestock. So there's things that, we need to eat, we need these ag lands, but there's a lot of things that we can do more smartly, okay? As far as forest, we've talked about this, okay? Clear cutting, that's when you have a forest and you just cut everything down. Well, the smarter way about doing that is what? Instead of cutting everything down, you do the selective cutting. It's because you don't want to kill all the young ones, and yet you don't want to kill all the older ones either. You need this variety there, okay? And then we have in the mountain area, okay? You have the timber and mineral extract. A lot of damage that goes in extracting those minerals because basically you have to blow up the earth in order to get it out. And there's only so much repair that you can do with that blowing up. Okay, as you guys are going to see when we go up to the Mitsubishi mines, they have actually, they'll never be able to make the land back the way it was. I mean, there's this big hole in the ground, okay? But they can improve what they have done, and they make these areas to where it encourages the wildlife to come back. And so you'll see that at Mitsubishi. Oh, another big one too, whether it's the forest or mountains, and we'll hear about this as well, is these off-road vehicles. Really highly damaging. Okay, what about it is so damaging? You guys know? It compacts the soil. So what's so bad about compacting the soil? Soil, let's say your soil might have been this thick, okay? And then after these off-road vehicles going over the same path time and time again, now it's down to this. Well, it has these pockets. Those pockets are air and water. And basically you just squeeze the air and the water out of the soil. Okay? And most, not all, but most seeds cannot germinate when it's that compacted. So that's a really big problem. The other problem it causes is they don't always stay on a trail, and they go making their own trail, and so you're causing erosion from the soil. So what's so big about that? That soil is going to end up running down the hillside, the mountainside, ending up in the streams, and it chokes out the wildlife. Not only does it choke out the wildlife, but it raises the water level too, to where there actually isn't as much water that can be retained. So with this slide here, we're going to get into the aquatic side of it. We were in terrestrial, now we're going into the water part of it. And 75%, just like our bodies, how much of our body is made up of water? 75%, same as the earth. 75% of the earth is actually made up of water. Okay? 71% of that is salt water. It's like, what a tease. Of all that water, okay, only barely 2% of what water we have is actually fresh water. And so that has been a big problem within the last, especially 5 years, when we came across this drought. Okay? A lot of people think, oh, we're out of the drought. You know what? Not completely. We really aren't. It depends on what section of California you talk about. Some areas, yeah, they're totally out of it, and then there's still other areas that they're still in a drought. And so what they try to do to compensate for this fresh water, lack of fresh water, is they created these desalinization plants where they can convert this salt water. You can't drink straight salt water. You'll end up dying, okay? So it converts the salt water into fresh water. Navy's been doing this for, hundreds of years, okay? But the downfall to that is these plants take a lot of money because we're dealing with salt water and it's highly corrosive. So it takes a special type of metal and material in order to build these desalinization plants, okay? And so when we talk about aquatic, we're basically talking about one of two things, either salt water or we're talking about fresh water. We tend to hone in more on the fresh water because that's what we drink and that's what we need. But there's so much that we get from the saltwater zones. So what determines what type of organism lives where it does in an aquatic zone is these 4 factors. Water temperature, okay? You have what's called DO, dissolved oxygen content, how much food is even available. Some, just like people, some people need more food than others because of metabolism. Same thing with, animals. Typically, if you're in colder water, it slows down the metabolism and they're not going to need as much food. And you get that. Anybody ever gone scuba diving? Yeah? Got to put it on your bucket list. It's so amazing. And so what happens when you go scuba diving, you'll end up hitting what's called a thermal climb. Did you ever hit one of these? It's basically, you literally feel this difference. You could you're here and then you swim over just to this and you feel this wedge of cold water all of a sudden. You get about 45, anywhere between 30 to 45 feet, depending on where you're at. And it's amazing, the different aquatic life that live in this cold section versus the warm section. Because our Pacific Ocean, it's cold. But then it gets even colder once you hit that 45 degrees. Okay? 45 feet. And another part that is a real major concept is the light availability. Because despite what most people think, why is there such a big uproar since like the 80s and 90s, not cutting down the rainforest in Amazon? Why not? The animals, okay? What else was the whole reason for people saying not to cut it? The oxygen. But what a lot of people don't realize, we actually get more of our oxygen not from the rainforest, but we actually get it from our oceans. And it makes sense. Let me put it in perspective to you. Have you guys ever been on beach and you know when there's that kelp that washes up on the beach? Okay, depending on what species that washed up, but there is one species called macrocystis. What does macro mean? Nope, other way. Large, macro, large. Okay, it has these large fronds. They're not really leaves, but it can photosynthesize like a plant, and it actually does it better than a plant. So good that macrocystis, that giant kelp, you guys know how fast that can grow in one day? Feet. 3 to 4 feet in one day. Yeah, so obviously these guys can photosynthesize really well. That's crazy, 3 to 4 feet. But think about it, why is that? Okay, anybody into hydroponics? Okay, what's the advantage of hydroponics, Kevin? Not Kevin, I just looked at Andrew, sorry.
You get more nutrients in the plants, don't you?
Yeah, if you're talking about a terrestrial plant, the only time it gets its nutrients is when it rains or after it's been watered, because that's where the nutrients is in the soil. But it can't get to it until it's been watered. Okay? Unlike hydroponics, it's in this nutrient bath 24/7. And it's able to take it in throughout all parts of the body. Unlike a plant, how does it get its nutrients? What part? Strictly through the roots. So basically, the giant kelp, or these aquatic plants, are in this nutrient bath 24/7, and they're able to photosynthesize that much better than a terrestrial plant. So when you talk about the oceans, we can break it up in different sections. Really, the most important one is the coastal zone. Okay, less than 10% of the world's ocean falls within this area, the coastal zone. Yet, even though it's only 10% of the world's ocean, 90% of all marine species live right off the coast. It's not what we call the open ocean, the pelagic species. Okay, anybody go deep sea fishing? Okay, so you're not staying along the coast. You're going out there. You know, it takes a couple hours to get out there. They're out in that open ocean. They're getting those open ocean species. But really, where most of the species are within this coastal zone. And what happens is they have this high net primary productivity. Like I said, that kelp, okay, phytoplankton, dinoflagellates, they're all able to do this photosynthesis, and they do it very, very effectively. So the higher the NPP, basically the more oxygen they're going to give off as a result. And then you have the open sea. But with the open sea, when you talk about the ocean, there's different zones. How far out you go, but then what else? How far down you go as well, like the abyss. Okay, that's where you see all those really weird, but I think really cool deep sea creatures. And if you ever wonder, like, where they come up with these ideas for these, sci-fi movies and everything, just look at these deep sea creatures, and you're like, oh yeah. So, natural capital as far as marine ecosystems. Okay, oxygen. This is actually where we get our oxygen supply. And scary stuff is happening with our oceans, unfortunately. Okay, the temperature is rising. And typically when you have this rising temperature, okay, it's not able to hold as much oxygen. Water purification. This is mainly when we get into wetlands. They're known for their wetland purification properties. Nutrient cycling. This one here, reduce storm impact. Well, Florida learned this one the hard way. And you know what? Even if there was still the Everglades and the mangroves like there should be, it can only do so much. But like I think it was in Indonesia, I just saw like 90% of all their mangroves have been basically turned over for fishing boat harbors. Okay, so what's the big deal about that? Well, mangroves, what happened to the barrier islands off of Florida? The Key West and all that. Yeah, it just there's nothing left. Okay, so these wetlands, basically they act like a buffer zone between the ocean and the mainland. And if you get rid of these wetlands, whether it's a mangrove, freshwater wetland, swamps, we don't have swamps here in California, but if we did, okay, it's not this buffer zone to help you protect you from that tidal surge or from that storm surge. You go straight from ocean to mainland. So now they're realizing, oh, maybe we should have kept some of that there. It wouldn't have solved the problem, but it definitely would have minimized the impact that Hurricane Irma had. And there's another one. There's like Jose. I mean, they're just one after another. There's all these that are forming in the ocean right now. And so what has happened is...
I want to make a note that it was the female one that was the vicious.
Ah, vengeance, right?
That's all I want to say.
Oh, yeah, I didn't notice that. Okay. Okay.
Hugo was bad, but he just kind of was lazy to stay in the same spot.
Yeah, he was
Remember,
lazy,
I
huh?
pounded a lot of-
She had more
was
force.
very angry.
Yeah, we do that. So, economic services, what do we get? Obviously food, okay? Sushi, whatever, fish, clams, oysters, all mussels. Energy, you guys might not know this, but there's these huge wind turbines that are out in the ocean. Not too much here in the U.S. yet, but you look like at Norway and everything, okay? You have these huge ones out in the middle of the ocean. Well, it kind of makes sense. There's always an ocean breeze. I used to think it was windy in San Diego and Ventura. Then I came to the high desert. I'm like, oh, used to think Chicago was windy too. It's pretty close, but the high desert, man, well, there isn't the vegetation to, knock down that wind. It just goes across the land. Pharmaceuticals, okay? Pharmaceuticals coming from Mother Nature. When they first started developing these medicines, it was plant-based. So these are all different types of economic services. Think about it. When you guys go, let's say you have the weekend off and you want to go have some fun, you probably go one of two places. You go to like an amusement park type of place, or you go to nature, whether it's go for a hike, you went to the beach, that sort of thing. Okay, so recreation, it's fun to go surfing, it's fun to go scuba diving, it's fun to go water skiing, it's fun to go fishing, all those things. And for me, okay, the reason why I liked it, that was my employment for many years. I got paid to walk on the beach, really? Okay, so this is showing you the zones for the ocean is not just horizontal, okay? We have that coastal zone that makes up 90% of all the marine organisms. At least that's what we think. There's so much there in the ocean that we haven't even discovered yet. It's kind of crazy. And then we have what's called the continental shelf. And what's so different and why our water is colder than it is on the East Coast. How many of you guys been to the East Coast ocean? Yeah? Way different. Yeah? The waves, okay? If you want to be a surfer or boogie boarder, you want to do it on the West Coast here. And the reason is because this continental shelf. Our continental shelf drops very quickly. And think about it. The deeper the water, what happens to the temperature? Colder. So ours is colder because that continental shelf, it drops a lot quicker. And what happens is as the waves come in, they feel the bottom and then they create bigger and bigger. Unlike on the East Coast, I've been to Nova Scotia, which is really cool because they have the world's biggest tidal regime, meaning the lowest lows and the highest highs. And so when it's low tide, you can walk out for miles, assuming that you're not going to sink, okay? But you can just see for miles and miles and miles these mud flats. And they have to compensate for it when they have their boats moored up along the harbor because of that the water. There's no water left in the Bay of Fundy, okay? It's totally gone. So you normally, moor up your boat with this much rope to keep it along the harbor so it's not banging and everything. But they have to literally have the rope this long from here to the window to account for that water leaving. It's weird. You see the boat floating and you come back 12 hours later or 6 hours later and it's there stuck in the mud. And you have to literally wait for the water to come back to lift the boat back up. Crazy stuff. So this is showing you here, again, there's that thermocline. Okay, once you hit that thermocline, that cold temperature, and there isn't as much photo or light that can hit, so you don't have as much photosynthesis going on, but it's still really important for the animals that are living within those areas. All right, so what have we done to cause the degradation of these systems? Coastal development. It's very hard to find a beach that hasn't been developed. Okay, and what's really ironic, as I'll discuss with you, no, not tomorrow, but next week, is where I used to work. If it wasn't for the Marine base, it's good that the Marine base is there, because more than likely if it wasn't, it'd get bought out and end up being commercially developed. The Marine base is actually protecting the wetlands that are there. Overfishing, okay? I don't know, how many of you guys just do freshwater fishing, okay? Things are different from when I was a little kid. You know, you just had, you know, your bobber and you had your worm and you cast it out. Well, nowadays you have these fish finders, okay? And so they have these really high-tech fish finders out in the ocean, and they have these nets, and they literally can capture a whole school of fish just instantly like that. They're very efficient, too efficient, actually. We have these different types of pollution, okay? A lot of it has to do with agriculture. Where I used to work, there was sod and then there were strawberry fields. And we had a lot of ag runoff, a lot of extra fertilizer that ended up going into the wetlands that caused harm. Habitat destruction. Overfishing. What do you guys see here? What happened? Yeah. So they catch this really awesome creature. Okay. I really love sharks. And they caught it, and they only use the fins for what's called shark fin soup. So it bleeds to death. And have you guys ever had like shark steak? Some good eat right there. I mean, it's thick like a steak. That you could have ate that whole animal. I don't have a thing against killing animals as long as you use the animal. There's so much that you can use of the sharks. I mean, you can literally use, you know, the teeth for tools. I mean, it looks pretty cool on a necklace too, right? The skin, have you ever felt a shark? Like if you've been to SeaWorld or the Aquarium of Pacific, it's like sandpaper. Well, they used to use it as sandpaper, okay? The corneas of the sharks, they use that for transplants nowadays. You can have a heart transplant, but you still can't replace the eyes. That's the one thing that we're still working on. But we can take the cornea of a shark and use that for humans nowadays. So they took this really awesome creature and only used the fins. How sick is that? Okay, so what effect do we have on the wetlands? Or, sorry, I saw the word wetlands, but on the ocean, it's just really, really huge. You know, we have the coral reefs. What's happening in the coral reefs? Neville's been to the Great Barrier Reef. Hate him. Yeah, okay. It's on the bucket list, amongst many other places that he's been to. Yeah. But what's happening with their coral reefs, especially the Great Barrier Reef? It's bleaching.
You know any problem with the Great Barrier Reef is?
The only problem. I don't. I've never been there, so I wouldn't know.
Australians there.
Oh. Did you have Vegemite?
South Africans and Australians.
Oh, you don't get along?
Because we're better than them in rugby. So.
Oh. So yeah, we have this bleaching effect going on. You know, sometimes when these movies come out, like Nemo or 101 Dalmatians, things like that. Well, everybody wants a Dalmatian after seeing the movie. Nemo, everybody wanted a Nemo or a Dory. And people don't think about that. Going back to this picture, what had a big effect on sharks? What gave them such a bad rap? What movie? Jaws. I mean, when I was a kid, that sound, dun, dun, and I'm in the bathtub, and I was even scared, knowing that nothing's there, you know? But yeah, Jaws. I mean, despite how much money he made, Steven Spielberg really didn't know the impact, the negative impact that movie was going to make. Because there was people literally would go on kind of like these witch hunt things, but shark hunts, just to kill the animal. Didn't eat it at all, but they were out to kill. How many sharks can I kill today? Okay? You actually have a greater chance of getting struck by lightning than getting bit by a shark. And if you get bit by a shark, why is that? They think you're a seal because you're floating on this, you know, if you look up from below, you look like a seal. believe it or not. I mean, with your wetsuit and the you're like, I do. I mean, you know. But yeah, you look like a seal, you know, that you're on the surfboard and you're hanging, you look like a seal. Because they don't eat the whole body. It's usually they took one bite, they're, oh, puh. They spit you back out. Okay, and then they realize that isn't what I wanted. Okay, so freshwater ecosystems. So two different types of freshwater bodies. It depends if, there's always different ways of categorizing. This way is based off of if it has water flowing into it or if it's standing water. So if it's standing water, it's called lentic. And if it's flowing water, then you have lotic, which the inland wetlands. The ones I used to work at were coastal wetlands, so that would have fallen in this. This isn't all that important. Just realize that, you know, you can have these kind of stagnant water supplies, and then you have fresh supplies coming into it, the tributaries as we call it. So here we go again, natural capital. What do we get from our fresh water? Well, obviously, the water we drink, right? Fishing, that's always fun to go fishing. Waste treatment. How do we have waste treatment here? Any ideas?
Algae.
Huh?
Algae.
What about it, the algae?
It doesn't it eat what we need taken out?
Algae can purify. What's really cool is you can do water quality testing based off of what's living there. Okay? Not just algae. Algae kind of gets a bad rap, okay? People always think, oh, I got algae in the water, it must be bad. Not necessarily. Okay, it's not just that it's algae. What types, which species of algae? Because depending on what species, that can let you know if you have good water quality or if you have bad water quality, just based off of the species. We did that in our phycology class in college. We did water sampling, and we had to identify the algae. Sounds really easy, but it's just LGB, little green blob, okay? That's what our professor, oh, what is that? And he goes, oh, that's a LGB, that's a little green blob. We're like, oh, thanks a lot, dude, you know? So we get all these different types of natural capital. Again, you know, recreation, transportation, we don't really think about it here, but you go along the Mississippi, that's the main way of transporting goods along the Mississippi is by boat, okay? This is just showing you the different zones. You really don't have to know. Again, do realize this is just how many of you have ever had a fish tank, okay? You have to know what its niche is because you don't want to buy a fish where they all are competing for the same food source. So you basically have the ones that are on the top, towards the surface, you have the ones that are along the middle, okay? And then you have the other ones, the benthic ones that are the bottom feeders, like your catfish. That way they're not all competing for the same resources. The other way that you can classify fresh bodies of water, these ecosystems, is based off the nutrient content and how well primary productivity, how well they're able to photosynthesize, okay? So there's these different categories here if they have low nutrients or high nutrients. Excuse me. Watershed drainage basin. This is a big one because that's what the whole Mojave is. We have a diagram here. When I first moved up here, I didn't understand the whole dynamics of the Mojave River. And it's really unique on two different aspects. Rivers typically are above ground and they drain into the ocean eventually, right? Well, ours does neither of those. What? Ours runs underground for the most part. There's some areas where it comes up, but for the most part it is underground. And then I heard Neville one time say this, how Barstow was accusing people in Victorville and all that of stealing their water. And I'm like, wait a minute, but they're up north. How does that work? Well, I didn't know that our river not only was underground, but it runs backwards too. Okay, and that's all, and I won't steal Matt's moment. He'll go into why that is when he comes back and talk with you guys. But it's pretty fascinating. We have both of those. It's rare to have just one of them, and then we have both. It's underground and backwards. Okay, so we're in this watershed area, and that's just a big fancy word for this drainage area. We're like in this collective ground area. Oh. The one that I've never really understood was this floodplain. Let's see here. Where I grew up in Indiana, there's a lot of farming that goes on, whether it's corn, soy, wheat, pick your crop, that just literally miles and miles as far as the eye can see. If you didn't see that, then you saw cows, okay? And I never, even as a kid, could understand why people insisted on building right next to a riverbed, because it's inevitable and it's meant to be that the rivers flood. This is the whole flood area. This is typically where you see agriculture happen. And there's a reason for it. When all those minerals that have been deposited into the river that have settled out, when it floods, it then all gets deposited out here, and it's highly nutrient. Okay? So it's very, very good fertile soil to grow. The disadvantage is by planting, growing in the floodplain, then, hence the name, you run in the risk of being flooded out. Okay? But why people insist, yeah, it sounds all cool and everything to have the river or even a creek in your own backyard. I think that's only cool if my house is up on a hill, or because it's going to happen. It's going to flood out. So you have these different zones here. Okay, you have the glaciers, you have the lakes that are up in the mountains, and it comes trickling down in this transition zone, which is between the mountains and this flood area. And you have these tributaries, you have these other creeks, brooks, or back home they used to call them cricks. I'm like, what the heck is a crick? These creeks that feed into the river and make it bigger. Okay? But what has happened is we have developed these systems such as dams, okay, these levees and dikes. Think about Hurricane Katrina. That didn't work out so well for them with these levees and dikes. It wasn't so much that they weren't big enough, although that ended up being part of the problem, but they didn't have them maintained either. The Army Corps of Engineers, they were told, hey, you need to make sure that they're up to snuff. Think about what happened just this past spring at what's called Oroville. You guys know what I'm talking about? Up north, with all the rain that we had, and there was this major dam, Oroville, and they were told several times by different agencies, you need to repair that dam. Oh, no. What do you know? 3 different independent agencies told them this, and they didn't. And what happened is not only did the water run over the dam, it actually cut around the side of the dam. Instead of flooding over this way, it ended up making a whole new pathway. Okay? So, we always try to control Mother Nature, but I like the saying, nature bats last, unfortunately. So these levees and dams, these dikes, what has happened is that our beaches are not being replenished. Okay, there's 2 things happening. We have, like the glaciers, they're melting, causing the ocean level to rise. So that's minimizing our beaches. But the other thing is these levees, dikes, dams, canals, they all hold back that sediment that would have naturally been brought down from our creeks and rivers and replenish our beaches. And so you might hear that they need to do dredging because it's not holding as much water because all that sediment got deposited, so they basically have to dredge it out and they need to transport it back down to the beach. They do this in harbors too. It'll get filled up with sediment. And what they did, over half of all the wetlands in the U.S. have been destroyed. More than 90% of the wetlands in our state are gone. Okay, you're like, well, what's the big deal? Well, there's a lot of, again, just that whole erosion control. That's a huge factor. I actually did it. Okay, so just make sure you go over these 3 main concepts. Again, for the next, I think, at least 3 weeks, we're going to hit different areas of the biodiversity. You know how I talked about specifically the genetic, the species, and all that. So we'll get into that as we go along. So Quiz 2A closes tonight. Quiz 2 is already open. Start working on your discussion board. And what else, Noel?